Assalamu alaikum. Today we are going to explain our LFR project. Me with my groupmates, Mr. Khubab and Mr. Jamshed, we done a project in our microcomputer and embedded system project. Basically, this project was in the session of BEMTS Fall 2022, A section, Supervisor Professor Umar Farooq. So let's start. So these are the table of content for our project. The chapter 1 includes proposal, initial feasibilities, comparison table of at least two similar products, technical standard, team roles and details, work breakdown structure, estimated budget. The chapter 2 includes introduction, objective, review, specification, schematic PCB design, block diagram and specification sheet. And the third chapter includes system for design, criteria, free body diagram, design calculation, component forces and torque. 4 includes these topics. Similarly, 5 and 6 includes these topics. Here we complete our table of content here with the final thoughts. So starting from the chapter 1, proposal, we were aiming to develop a line follower robot equipped with various sensors and modules to navigate predefined paths, detect obstacles and provide real-time feedback. Initial feasibility studies were conducted to assess the technical and financial feasibility of the project, the availability of the component, feasibility of integration and estimated cost were evaluated. These are the comparison table of rubber robot and the snake. Obstacle avoid, yes. Line follower, yes. Color detection was okay. Slope was 30 degrees and speed was 7 centimeters per second. Battery timing was 7 minutes. IoT enabled and cost was round figure about 7,000. Technical standards such as speed required for the robot movement and the sensor accuracy were established based on industry's norms and project specification. These are the team roles and details. I assembled the project. Overall assembly was under my task, PCB and soldering. So I designed little bit of PCB, assemble all the project, and the hardware was my task. Khubab done the lab report making, components balancing, and Jamshed planned about the PCB designing and coding. Here are the signatures for all the teammates, roles and their signatures and their name. These are the component details and the chart. Here our estimated budget and overall receipt of our project cost depend. So starting with the introduction. The introduction provides an overview of the project, outlining its objective scope and significance in the field of robotics. Objective: the line robot, equipped with the infrared and color sensor, SD card module, OLED screen, Bluetooth module, ultrasonic and current voltage sensor, aim to autonomously navigate predefined paths, detect obstacles, and provide real-time feedback, integration, communication wirelessly with ultrasonic sensor for obstacle detection and current and voltage sensor for performing monitorization. The robot ensures efficient and safe operation, filming its objective of automated navigation in weird environment. List of the features and operation specification. The permeability product specification was established, outline the feature and operation requirements of the line following robot. The project processing of the mechatronic system includes conceptualization, design, prototype, and testing and discussing in this session. Here is the schematic diagram of our project. Here you can see the component list in a way, and here is the PCB diagram with our roll number and name enrolled. Here is the complete block diagram of the robot. All the input parts are on right side and output parts are on left side. Here are some specification sheet of our LFR project. So coming towards the product design, system considered for the design. The product design process involved careful considering of various system requirements to ensure the final design would meet all function and perform criteria factors as the size, weight and power requirements of the robot were analyzed. Criteria for component selection. What were our criteria for component selection? This selection of component for the robot was based on the final approved project specification, which outlined the requirement performing metrics and functionally. Free body diagram. The free body diagram was created to illustrate the force acting on the robot and to determine the center of gravity. These diagrams are essential for ensuring the stability and the balance of the robot during operation, as they help to identify areas where additional support or the counterbalancing may be acquired by carefully analyzing these diagrams. So these are the free body diagram calculation. So coming toward the chapter 4, mechanical design. The selection of the mechanism for the robot was based on a detailed analysis for the recruitment and construction of the components of the product. 4-watt driver. 4 wires. Driver typically controls devices like stepper motors, resistor, or transfecting. Platform design. The design of the robot platform was criteria for ensuring stability during durability and the areas assembly. The platform was designed to accommodate all the requirements. Material selection. Choices of the material for the robot construction was based on a thorough analysis of the mechanism, property and the cost material. 3D CAD design and analysis. The mechanism design of the robot was developed using 3D CAD software to create detailed model of all the component assembly. Maximum stress analysis. Factors, safety and maximum stress analysis were conducted to ensure the robot component would be able to withdraw the expected load and force during operation. Additional information and the innovation solution depends to overcome these challenges. Coming towards chapter 5, component selection. The main different tasks. The main motive was to select components. There are three Arduinos, Mega, Uno, or Nano. The main task was to choose the right Arduino. So we choose Mega, IR sensor, ultrasonic sensor, color sensor, voltage and current sensor, SD card module for wireless communication, L299 motor driver, motors, OLED, Bluetooth modules, encoder, and ESP32. These are the specification of these components. The power requirements for the robots were calculated based on the power consumption of the working component and the expected operation condition. A power supply system was designed to provide the necessary voltage and current to all components, taking into accidental factors such as efficiency, reliability, and safety. So Mega, these are the components and they are working. Mega 2560 is a powerful microcontroller board designed for projects that require abundance of one or input-output pins. So Mega, choose the appropriate board type in toolbox menu at Mega 2560 microcontroller. Select the serial port. Infrared sensor are used for the radiation that converted into the form of interpreted or measure how they work. Emitter and receiver. There was a code for emitter and receiver in it. As you can see the infrared picture. Ultrasonic sensor. Ultrasonic sensor was used to measure the distance by using sound waves. Here is the picture of the ultrasonic sensor. Color sensor was for the obstacle avoiding. We use red color as the obstacle avoidance. So when the red color came into the LFR, the color sensor detects that it's an obstacle and change the size. Current and voltage sensor. You can see the pin out of voltage and current sensor. We put a SD card module to save the storage so we can use later when the power is cut off. L298 motor for driving the motor. It is a motor driver. OLED display. So we can display our measurement distance and see on the OLED screen. Bluetooth module for the communication wireless. So you can see the pin output VCC, ground, TX and TR. The main pins are TX and TR of the Bluetooth module. Encoder was put it to measure the speed. You can see the power indicator, switch indication, LM393 and OP2 interpreter. So these are the pin output of the system. Coming towards the chapter 7, which was the project with state machine diagram. Any additional information or details relevant to the simulation and final integration phase of the project could be included here. This includes discussion of simulation result, lesson learned, and recommended for the future base. So we can learn about many factors. Final testing phase involves comparative testing of the entire robot system to ensure that it met all design specifications and perform requirements. The projects performed were evaluated based on its ability to follow a line accurately, avoid obstacles. Individual contribution. As I tell you further, I covered the hardware. Hubaib makes lab reports and Jamshed designed the PCB and did its code. So we get a good feedback from the project. Our project failed on our first attempt but passed after further changes in our project. So you can see the 5 applications of our project. It can be used in industrial automation, warehouse and logistics, education and STEM learning also, home assistance, retail guidance and customer services. The project involves the design and implementation of the line follower robot with various sensors and modules for navigation and communication. The robot was able to follow a predefined path, avoid obstacles, and communicate its status using OLED and Bluetooth modules. In conclusion, the project was a valuable learning experience that allowed the team to apply theoretical knowledge to practical problems. The robot successfully demonstrate the effectiveness of the mechatronics engineering at preparing students for a real life challenge. So here is the appendix and data sheet of ATmega and similar projects like ESP32. Here is the final image of our line follower. So that was it, the working video. I will attach the working video.